So let's talk about teaching an AI how to think. It's not some kind of magic trick. It's more like a recipe. And today, we're going to unpack the secrets of that recipe. We're diving deep into exactly how these big language models are trained to reason. Okay, so let's just jump right into the biggest, most fundamental question here. Is AI actually learning to solve problems logically, step by step? Or is it just getting scarily good at faking it, at pattern matching the right answer, without really understanding why? This is, without a doubt, one of the hottest debates in the field right now. And that debate really breaks down into two main camps. On one side, you've got the capability refiners. They think all that special training you do later on, like reinforcement learning, where you're basically giving the AI rewards and penalties, well, they think that just polishes up the skills the AI already has. But on the other side, you've got the capability extenders. And they argue, no, this later training can actually create brand new reasoning skills from the ground up. So which one is it? Well, to finally get to the bottom of this mystery, a team of researchers at Carnegie Mellon University realized they couldn't just keep studying existing AIs. They had to go back to square one and build their very own AI laboratory. And here's the problem they were up against. Most of these models are trained on this gigantic, messy, kind of mysterious soup of data that's just scraped from the entire internet. You've no idea what's really in there. And that makes it pretty much impossible to run a clean, scientific experiment to figure out, which ingredient in the training actually caused which new skill to emerge. So what they do? They built their own controlled world. Forget the messy internet. They created a totally clean, synthetic environment where they could control every single piece of data the AI ever saw. And the key to this whole setup was something they call synthetic reasoning tasks. Just think of these as custom-built logic puzzles or math problems. Because the researchers designed them from scratch, they knew every single step of the reasoning required to solve them. This gave them the power to systematically change just one thing at a time, like how hard the problems were, and then see exactly what effect it had on the AI's learning. So with this perfect little lab, they could test for two really crucial types of reasoning. First, there's depth. Can the AI solve problems that are way harder, with more steps, than anything it was trained on? And second, there's breadth. Can it take a skill it learned in one area, say about animals, and apply it to a completely new topic, like teachers in a school? And once they got this lab up and running, it started spitting out some really fascinating clues about how AIs learn. The first one is what we can call the Goldilocks Zone of training. It really gets at the question, what kind of practice actually makes an AI better? Okay, take a look at this chart. It lays it all out pretty clearly. What we're seeing here is how well the AI performs based on how difficult the training problems are. Now, the line you're really known to watch is that orange one. That's where the AI is being trained on problems just a little bit harder than what it can already do, what the researchers call its edge of competence. And wow, look at that performance shoot up. The blue line, training on stuff that's too easy, and the green line, training on stuff that's way too hard, well, they just don't give you nearly the same boost. So, what's the big takeaway here? It's that for an AI to get genuinely smarter, it needs to be pushed right into that sweet spot. It needs problems that are tough, sure, but not totally impossible. That's the zone where the real learning happens. All right, on to our second clue, which kind of builds on that last one. This one tackles a really fundamental question. Can an AI just learn a totally new skill from scratch through practice alone? Or does it need some kind of seed, some initial foundation to get started? And this graph just illustrates the answer perfectly. It's pretty dramatic. Look at that blue line. When the AI has seen just a tiny fraction of a percent of a new topic, it just completely fails. It can't generalize. It can't learn. But then look at the orange line. With just a tiny bit more exposure during its initial training, it suddenly clicks. It starts succeeding, solving even the really hard problems. So what's the magic number? You're not going to believe this. It's about 1%. Just a 1% seed of exposure to the basic concepts is enough. That's all it needs to later build on that foundation and master a whole new area through practice. It proves an AI can't just create knowledge out of thin air. Now, this is where the investigation gets really interesting. The researchers uncovered a third clue, a super powerful but often totally overlooked middle step in the whole training process. Think of it as a secret bridge between the AI's general knowledge and its specialized practice. So we usually think of AI training in two big stages, right? First, there's the massive pre-training, where it learns about everything. Then there's the specialized reinforcement learning, where it hones a skill. But what this research shows is that there's this crucial intermediate step they call mid-training that perfectly bridges that gap and gets the model ready for focused practice. And does it actually work? Oh yeah, the data here speaks for itself.
That blue line shows the performance of a model that got both mid-training and that specialized RL practice. The yellow line is just the RL alone. And you can see, the combination is consistently better, especially on the harder problems. We're talking a performance boost of over 10%.
The big takeaway, then, is that this mid-training thing isn't just some optional extra. It's a really powerful strategic tool. It's like a dial you can turn. You can adjust the balance between mid-training and reinforcement learning depending on what you want the AI to do, whether you need it to be super reliable on things it already knows or get better at exploring brand new, complex challenges. This brings us to our final clue, and honestly, it might be the most important one of all. It's all about making sure the AI isn't just guessing the right answer. In other words, you have to make it show its work. See, the standard way to train an AI is with what are called outcome rewards. It only gets a point if the final answer is right. The problem is, this can lead to what's known as reward hacking, where the AI finds some weird shortcut to get the right answer without actually using the right logic. It's basically cheating. The better way is with process rewards, where you grade every single step of its reasoning along the way. So, does checking its work actually make a difference? You bet it does. This chart shows that when you start mixing in these process-based rewards, you get a really significant 4 to 5% performance jump on the hardest problems. It forces the AI to learn sound logic instead of just finding clever shortcuts. So when you put all these clues together, a really clear picture starts to form. Getting an AI to truly reason isn't about finding one single magic bullet. It's about the careful, deliberate interplay of the entire training process, from start to finish. Which brings us to the final verdict. The recipe for creating an AI that can reason has 3 absolutely essential ingredients. First, you need that solid foundation from pre-training. Second, you need that mid-training phase to act as a crucial bridge. And finally, you need that targeted Goldilocks practice that both challenges the AI and rewards it for showing its work. What this research really gives us is a much clearer, more scientific blueprint for building smarter, more capable AI. It answers that big question from the beginning: can AI truly learn to reason? With a qualified yes, but only if we follow the right recipe. And that leaves us with one last, really tantalizing thought. Now that we have the recipe, what incredible new frontiers of reasoning will AI conquer next?